now that you've learned how to test your code, whether you do it by implementing your functionality and then testing it using unit tests, or using the test-driven development process and creating your test code first and then implementing the functionality, one of the things that you're going to want to start doing is calculating metrics of test. And one of the automated metrics that you can start working with is something called code coverage. And that's what we're going to talk about in this section today. So one of the things that code coverage does is it answers a question and leads to the answering of the question of how do you know if you've properly tested your code? Remember back when we first created a unit test and I just put in a static value that was in there of a 2 and a 3 for our addition, and then we realized probably want to check some other numbers than just those two, and so we added some random values that are in there. Well, that question of how do you know if it's been properly tested, it's a complicated question, and it requires a complicated answer. One of the things that you can do to help see if you're doing things correctly is something called metrics, and looking at those metrics. Those metrics might be how many requirements are passing. It might be how many lines of code there is. Another metric is something called code coverage. Code coverage is a metric that we can use to help identify the completeness and effectiveness of a unit test. But one of the things that I really want to emphasize is it's not a quality metric. So code coverage, and I'll explain a little bit more of what this is in just a minute, but code coverage may be 100%. You may have full code coverage, but that doesn't mean that the unit test is a good test. It doesn't mean that it actually tests the functionality of the code or the requirements. It's not necessarily something that we want to do. It just executes the code. Good job. We need to look at also other things than just code coverage to do that. It doesn't mean that code coverage is bad or it shouldn't be used. It's most definitely a very, very important metric, but it shouldn't be the only metric that's used in doing that. When we look at code coverage, there are really 5 different main areas of code coverage. The very most common one that you're going to see is statement coverage or line coverage. The number of lines of code that have been executed. And all of these are measured in percentages. So the percent of code. So if you've got 5 lines of code that are executed out of 10, you have a code coverage of 50% line code coverage. The next one up you might have is function coverage. That's in there, and that is looking at all of the different functions that may be as a part of the scope of what you're testing, and if those have been executed or not. It's kind of a broader area that's in there. The next thing you might have is edge, and that's looking at the different edge conditions and those types of things. You have branch, which is looking to see if when you look at your if statements and your for loops and those types of things, did you get each of those branches that might be in there? And then you have condition, and that may sound similar, but actually that is where you look at the actual conditions within an if statement and you look at all of the truthiness of it. So if you're comparing 2 values inside of an if statement by chance, you want to check to see if those 2 values, if you have a true and a true, or a false and a true, or a false and a false, or a false and a true, or true and a false. I'm not quite sure. I missed something there. Anyways, so that is what you're kind of doing there. For today, what we're going to talk about is just statement coverage, talking about the lines of code executed there and seeing if that's been coveraged. And Python actually has this interesting module called coverage.py that you can use to capture that code coverage. Now, this isn't something that comes pre-installed with Anaconda, so it is something you're going to have to install additionally. whether you use the Anaconda Conda install coverage or you use the pip install coverage in there. But that's just that's the execution that you have to do, and it is something that you're going to have to additionally onto there. So let's switch over back to our test cases and let's run some code coverage and see what that looks like and how that operates that's there. So here we are again with our calculator class and tests, and what we want to do is do some coverage. So the first thing that I'm going to do is actually install the coverage tool. So we can do this by you running the Conda install coverage, or if you're not using an Anaconda environment, you can use pip install coverage. Both ways will get that for you. After having that installed, it's actually really easy to use. Executing it is just simply running the coverage command. So if you ran your unit test by using the command python-m unit test, you would actually run it by doing coverage run-m unit test, just like that. And now we can see that it ran, all our tests passed, and that's perfect. But what about the coverage? Well, you can see that it generated a file called coverage, or .coverage. It's a binary file. It's got a bunch of data in there. But before we explore that data, let's see how we would run this for PyTest. It's just simply coverage run-m PyTest. Get the exact same results as we would expect. But now let's look at that report. Coverage report gives you a report of the coverage. You can see that calculator.py has 9 statements and 0 of them were missed. So we have 100% coverage in there. So let's do something interesting. Let's actually comment out the divide code and rerun this. So again, coverage run -m PyTest. We get all 3 tests passing. So to us, we don't see anything is wrong with our testing. But now we can see that only 89% of our code has been executed. So we're missing 11% of that. What we can also do is look at the HTML of our coverage. And that is done by running the command coverage HTML. And that'll generate a folder that has a bunch of HTML outputs that shows the coverage that's in there. And we'll go ahead and open this file in a browser. And we can drill into that file, and you can see there, line 12 has a missing execution. Now you may notice that there's an interesting thing happening here, that line 11 is being executed, but not line 12. Well, that's because when Python defines the classes, line 11 will be executed as a definition as a part of that class. So we can see that add gets defined, and then the subtract, and then multiply, and then divide. Each one of those gets defined as the class is declared, but it doesn't get executed. And so that's where the content within the method has to be executed first. So we can see that that's missing because of our test. So there you go. Coverage is a great tool for us to be able to identify potential gaps in the tests that we're missing or writing, or even missing tests. It's a great way to see how well you're testing as well, like if you're missing some areas. But remember, code coverage isn't the only thing you should be focusing on. You should look at all your other metrics as well.